Welcome, everyone. So we will go ahead and get started with today's review session. So we are going to be covering sections, predominantly section 8.1. However, if you have any questions on 8.2, we can totally field those as well. So that's going to be arc length and areas of revolution. Do you guys have any initial questions to start off? Feel free to put them in the chat. Do you guys have any specific questions about the homework that's due tonight or anything like that? Find the arc length of y is equal to 2 times x to the 3 halves, starting at 25, 250. That 25, 250, Rocco, is that an xy coordinate?
Yes.
Could you say that again? I wasn't able to hear you. Yes, awesome, thank you. Cool. So, go ahead. Cool. So, starting at 25 to 50, I'm going to find the arc length of y is equal to 2x to the 3 halves. All right, cool. So in the case of this guy, what we want to start off with, excuse me, is going to be really just the equation that we're aiming to get. So in terms of arc length, our length L is going to be equal to the integral from A to B of our square root of 1 plus f prime of y squared. That'll be in absolute values there. And then dx, and this can of course be substituted for f prime of x, and then have a dx on the outside and such. So with this problem specifically, since we're only given a starting point, we are going to be working with a slightly different bounds. So we're going to be starting at A and going to X, which is a little gross, but nothing too crazy. So the first thing that we're going to need to do is figure out what our y prime is going to be. So if y is equal to 2x to the 3 halves, then our dy dx is going to be equal to 3x to the 1 half. And so that is by saying that 3 halves comes down. That 3 halves comes down, it's multiplied by 2x, and then it's going to be 3 halves minus 1, which takes us to that 3 and that 1 half. So the 2's cancel out right there. So now that we have this guy, we can go ahead and plug it in so that we have our L is equal the integral from A to X of the square root of 1 plus, and it's going to be this 3x to the 1 half squared dx. So then we can simplify to say that it's from A to X of 1 plus 9x dx, which isn't too terrible. Now, since we want to put it, or since we only have a starting point, this 25, our A is going to be equal to 25. We'll just keep this as x, but we're going to start writing it a little bit differently. And we're going to replace these x's in here because we can't have an x both in the equation and in the bounds. So we'll go ahead and say that instead of L, this is going to be like some function s of x is going to be equal to 25 to x. And we're still going to use the same square root of 1 plus 9x dx, but instead of x's, let's put t's. It's a good neutral one. 1 plus 9t dt. And so once we're here, we can take this integral just like we would any other. So let's see, so we'll have 1, we can rewrite this as 1 plus 9t to an exponent of 1/2. Then, let's see, what's going to pop out in front? The 9 will pop out in front. And so we have 3/2, so 2/3 times 1/9, not 1/2, 1/9.
Use substitution.
Oh, use substitution. No,
It's probably in this case. Because I'm getting u to
Oh,
1/2.
yeah. That's true. It's a much better route. Cool. Yeah, so let's go for a u sub then. So u is going to be equal to our 1 plus 9t. Our du is just going to be equal to a 9 dt. And so then we will have 1/9 du is equal to dt. We can rewrite our stuff. That's fine. We can rewrite this as taking the integral of u du and then just have this 1/9 out in front. Just from the constant, that'll just carry over in front. And so from there, that becomes 1/9, and that is going to be 2/3 u to the 3/2. Yeah, a lot better than trying to do that in your head.
Yeah.
And so then now we can go ahead and re-put that into this sort of form. So then we have from 25, actually that'll be in a different spot now. So we'll have 1/9 times 2/3 times our 1 plus 9t, and that guy will be to the 3/2. And then that'll be put across our bounds that go from 25 to x. So let's see. If we simplify this, this comes out to 2/27. So if we keep that moving forward, then we'll have 2/27 times 1 plus 9x quantity to the 3/2 minus 2/27 1 plus 9 times 25 to the 3/2. And so once you simplify this numeric portion on the right, this will give you your arc length in terms of a function. Does that make sense? Because if you aren't given, if you're only given a starting point, if you aren't given an end point, then the farthest that you can go is just finding the function that you'll need. Any further questions from you guys before I just go over some general stuff, some general problems? Anything, yeah, anything from 8.1? Yeah, cool. Definitely go over one from 8.1. Let's see. Let's go over number 5. Number 5. Sweet. So 8.1, sign number 5. Sweet. So in this case, we want to find the arc length of a curve from 2 different points. So our point P is given as 1, 5, and Q is given as, let's see, I have 27, 13. Hopefully yours are kind of similar. And then the function is x squared is equal to y minus 4 quantity cubed. Sweet. So we know that we need to get it into a function that is equal to either a singular x or a singular y and go from there. Since we're given this in terms of x squared is equal to something something y, let's just keep it in this form and rewrite it as x is equal to y minus 4 to the 3 halves. And that happens, we change this 3 to the 3 halves because we're taking the square root of either side of this, and the 3 halves is how that simplifies. So now we can find a dx dy. So that is going to be 3 halves, y minus 4 is going to be to the 1 half. And then if we keep the chain rule in mind, we would just multiply by an additional 1 from the inside. So that won't change anything. And so now to make sure that we have our a to b 1 plus f prime of y squared dy. Now we need to just square this bad boy, which shouldn't be too bad. So if we square this 1 half term, this y minus 4 will just be a y minus 4, that exponent will go away. And then the 3 halves will then be squared. So that'll become a 9/4. So that means that we will have a to b square root of 1 plus 9/4 times y minus 4. And then a dy. Sweet. And let's see, if we wanted to simplify this even further, we would distribute this 9/4 to the y and also to the 4. You get 1 plus 9/4 y minus 9. Sorry, my y's and 4's look a little similar tonight. And then that would simplify to 9/4 y minus 8. Cool. So because we are dealing in terms of y, when it comes to what we choose our a and b to be, we want to use the y values from these given points. So since we're starting at p and going to q, we will say that this is from 5 to 13. And it'll be the square root of 9/4 y minus 8 dy. And just like in the previous problem, you'll want to use a u sub. So we'll say that u is equal to just everything that is underneath that radical. So our du is then just going to be a 9/4 dy. And so that means that this guy will flip and go to the other side. So that 4/9 du is equal to dy. That then becomes the integral of the square root of u du. Remember to carry out that 4/9 in front. And then you get 4/9 times the integral of that square root of u, which is going to be 2/3 u to the 3/2. And so when we switch that back to y, we can then also move our bounds to the opposite side to then evaluate, so that we get 4/9 times 2/3 times 9/4 y minus 8, and that'll be from 5 to 13. Cool. And so another option that you would have had, instead of evaluating at this point, you could have changed your bounds to be in terms of u, and then done that right here, in terms of u1 and u2. And you would have done that using your 5 and your 13 and this equation for u. But I just prefer to plug in my y and then go from there. A little bit less work, but a little bit more work at the same time. It evens out. So once we get to this point, we can simplify and plug stuff in. This 4/9 times 2/3, that becomes 8/27. So you can carry that through 8/27 times 9/4 to be 13 minus 8, and then minus 8/27 times 9/4 times 5, and minus 8. And you can plug it into WebAssign, and that would probably be accepted. I don't think there would be any problem with that. It likes to simplify on its own quite nicely. All right. So then, let's see. Everything else on the 8.1 homework is pretty self-explanatory. There's nothing too crazy going on. It's always a good idea to get comfortable integrating with respect to y instead of x, because that'll be really important in 8.2 when you guys tackle that homework later this week. Let's see.
One of these two. One or two.
Oh, this one's literally on the homework.
Oh, for the other three.
Yeah, let's do number 3. Why not? Cool. Or problem 6, part 7. Sweet, thanks, Steve. Oh, yes. Excellent, thank you. Cool. Oh yeah, so going from, yeah, so hitting up the x. So with that one, it is, if we go back to the first problem here that I did, all that it's asking for is you to rewrite part 6 in terms of t. So where in this problem I had a 1 plus a root of 1 plus 9x, I had to write that in terms of t to make sure that I satisfied having this x in the bounds. And so then in terms of your problem where you have 6x plus 1/24x, no, it's okay. WebAssign's a little bit tricky to think about sometimes. But yeah, you just have 6t plus 1/24t. And that should solve your issue. Yeah, so let's tackle another one. So yeah, let's give number 3 a go. So this one is WebAssign number 3. So this guy is going to be x is equal to y to the 4th. Oh wow. I apologize in advance if all of these are about to look the same. So y to the 4 over 8 plus 1 over 4 y squared. I'll make it extra stylized. So then it goes from 1 to y. Let's see. 4, why not? Let's make it up as you go. And so then with this guy, in finding your dx dy, you can either take it at face value. What I like to do though is make sure or rearrange and rewrite so that all of my exponents are in the numerator. So when it comes to this 1 over 4y squared, we can rewrite that as 1/4 y to the negative 2. And that'll be a little bit better. So then, actually that's not going to be our dx dy. That's still going to be our x. And so then in taking that dx dy, it makes it a little bit easier. So in this case, we'll have 4 times 1/8 y cubed, and then plus 1/4 times is going to be a negative 2 times y to the negative 3. Sweet. So then, going from there, that simplifies out so that we have a 2y cubed minus 1/2 y to the negative cubed. And so then you can go ahead and square that. And it'll be a little bit better. Except when you square that, you have to remember to treat this as a polynomial. You can't just go in and square the individual terms, as much as I would really like to. But let's go ahead and rewrite this in terms of how we would tackle it in an integral form. So that means that our arc length is going to go from 1 to 4. And it's going to be the square root of 1 plus, and we'll just write out this whole polynomial in here, 2y cubed minus, I'm going to simplify it, 2y cubed squared. And so these polynomials here are equivalent. And just like I simplified by switching things up here, I use the same concept to take that y to the negative 3 to a 1 over 2y cubed. And forget our dy. Sweet. So now let's go ahead and expand this guy. So 2y cubed minus 1 over 2y cubed times itself. So that will make 4y to the 6th minus 2. So when we multiply these, they'll both be equal to a minus 1, adding to a minus 2, and then we'll have plus 1 over 4y to the 6th. So then we'll go from 1 to 4 of 1 plus what we just found. And then, let's see, from there, Did you do it?
Sure.
Oh, it just simplified.
Yeah, I
Okay,
just combine terms.
cool. So when you combine these terms, then it comes out to square root of 4y to the 6th plus 1 over 4y to the 6th, and then it's going to be a minus 1. I guess you should put that minus 1 in the middle. But oh, this is a different problem. That's not. Still a really, wow, math brain is not going to. Cool. Yeah, so once we're at that point, this pretty much simplifies down to just a 4y. Oh, it's doing what?
Or I guess completely
Where did I
switch.
mess up? Did I mess up?
I have a 1/2 going on there.
1/5. Mhm. You have a minus 1/2 and I have a minus 2. Well, let's see. How do we get a minus 2?
I don't know. Can you square this? Yeah, because that's just
Because
gonna
the
cancel
minus
out.
2 becomes minus 3. That 2, the 1. Wait, did I drop it? No,
So that
I
part
didn't
looks
drop
good.
it. Those cancel out and it becomes a minus 2. Because it's 2 over the 1/2.
So did I mess up?
You messed up.
I messed up.
But wait, they also have a 1/2. Oh no, they don't.
So did the -2.
Wait, no, they do have a 1/2. What? They do keep it in the -3 though. Huh. So folks, somewhere along the way, this -2 should actually be a minus 1/2.
I'm trying to figure
Is
out
it?
where it goes now.
Oh, but they also have a 1/4 in front of theirs. In front of it. Whoa. Oh, haha. 4 over 8 is not 2, it's 1/2.
Oh, I gotcha.
Okay. Cool. Crap, that was really early on. Yeah, so this is where I messed up today.
Just put that up there.
Oh, fine. Yeah, all right. Yeah, so that should be a 1/2. This should all be 1/2. I'm sorry about that, guys. Which means this will be a 1/4. Means that that will be, yeah. Yeah, that will be a minus 1/2. And then we'll have the 1/4 y to the 6th. That makes so much more sense. So these are all 1/4, 1/2, 1/4. And this, let's see, we're simplifying at that point, so that becomes a plus 1/2. And so, yeah,
Just
there we go.
makes-
Yeah. So at this point, now this is where this simplifies to just y cubed plus 1/4y cubed squared. And since we have the square root over it, the radical and the squared cancels out.
should be 1/2. Because having that term, so then that ends up
Okay. Okay. Well, I'm glad I'm not getting a degree in that. Okie dokie. You're still going from 1 to 4. So now you have from 1 to 4, the radical goes away, and you're just left with 1/2 y cubed plus 1/2 over y cubed dy. Well, let's just rewrite that since it looks kind of wonky. Y to the -3. And then you go from there. And you should come out with, let's see, should come out with 2055 over 64. Okay. All right, geez. Cool. Do you guys sort of get the gist of 8.1, or would you like to go over another one for homework? The last problem. Last one. Oh, yeah. Gross. Okay. I got you, Steve. All right. So this is going to be 8.1. 8.1 number 8. Sweet. So in this case, we have y cubed is equal to x squared. And initially we're told to sketch. So the first thing that I want to do is put this in terms of y, or not in terms of y, in terms of x. So we have y is equal to, and so we're going to take, I guess, the cube root of both sides. And so that means that our y is going to be x to the 2/3. So we want to sketch the technical term, sketchy sketch. Like such. Let's make baby t table. So if we have 1, our y is going to be 1. If we have -1, that's good.
2/3.
Yeah. This fraction.
It's gonna be negative.
No, it'll be positive.
Oh yeah, this is just the cube root of 1. This is cube root of 1 squared. Right?
Yeah. Yeah, approaches the cube root of 1 squared, which would just be always positive. And that'll make it nice. So if we have like an 8, 1/3 of 8 is going to be 2, squared is going to be 4. And if we have a -8,
Same thing.
so yeah, also be 4. So we have a 1, 1 and a, say, all the way out here, means we're going to have something that looks kind of like this, and it is going to be symmetric along or around the y-axis. So it should look something like that. And so then now it asks us to use the following formulas to set up arc length from 0, 0 to 1, 1. So going from this point here to this point here. So this is going to be the section that we're taking a look at. And so it asks you to do it in terms of x and y. Okay. So we know how to do it in terms of x. So if we were to set this up as a dy dx, then this would become 2/3 times x to the negative 1/3. Right? And then if we were to square our dy dx squared is going to be equal to 4/9 x to the negative 2/3. And then since we're going in terms of x, we use the x values from our two given points. So we'll go from 0 to 1 of the square root of 1 plus 4/9 x to the minus 2/3 dx. And then you could go and integrate from there. If we want to write this in terms so that we have a dx dy, we need to go back to our original y cubed is equal to x squared. So we want to write this in terms of y, which means that we have an x is equal to the y to the 3/2. And so then our dx dy is equal to 3/2 y to the 1/2. And if we were to square it, then we would have 9/4 y. So that means that we'll go from 0 to 1 again because they match. 0 to 1 of square root of 1 plus 9/4 y dy. And so of the two, I would say that this guy here, in terms of x, is going to be a nastier integral. In terms of y here, you're just going to want to use a u sub. With this one, let's see. Not a u sub. Yes.
It's not gonna be pretty, but you could use something.
It would not be pretty. So this is a prime example of why you want to definitely make sure to see if one way is easier than the other. Steve, do you want to go over this integral specifically? Or was your question about the last problem generally? You find the length of the curve, which one do you use? Oh, for part C. So really, oh, yeah, so they give you the points in terms of x, y. So x1, y1, x2, y2. So you could use either one, really. If it marks both of them as correct, then you should have matching values for each of them. So it won't really matter if you use your one for x or your one for y. Dx, dy, you can if you'd like. I would use dy dx. I would use this guy right here just because it's an easier integral. But I guess once you have the integrand, once you have the product of the integral for both of them, you would just change the bounds on it. So yeah, you can really use whichever one you want. In the case of arc length, really does not
It
matter.
shouldn't matter. You should get the same answer for both of them.
Yeah. Yeah, no problem. Thank you. I really do not want to do the nasty one. And given my track history from tonight, I don't think you want me to do it either. So, do you guys have any more questions? We've got about 10 minutes left. And I know that you guys just started 8.2 today. And it's pretty similar to 8.1, just a different.
Yeah. It's close. Just a constant, or not necessarily a constant, if there's a different factor that's multiplied.
Yeah, just a factor in front. Not too
So
terrible.
same overall idea though.
Well, if you guys don't have any more questions, and if you don't want to go over 8.2 at all, then we'll just call it a night. Sweet. So thank you guys for stopping by. We appreciate the work. Yeah, no problem. Hope that these are super helpful for you guys. Great, and yeah, good luck with the rest of your week.